Okay, today is April 24th. We are continuing on with section 10.1, exponential functions. Before we start with the lesson, though, we're going to have a little review of some old rules because these are the things that we're going to be applying. You need to write this in your notes. Let's review what our laws of exponents tell us to do whenever we are multiplying, dividing, and adding or raising powers to powers. Okay, so let's go with something we can easily recognize. If you're going to multiply two expressions, first off, identify what is the base of each expression.
X.
X. If the base is the same, then you apply the law of exponents. You can combine the base. And what do we do when we're multiplying x times x? What do we do with the exponents? No, we add them. All right, so if you are multiplying two bases that are identical, then you add their exponent. Does the base change? The base is still x. If I have x squared raised to the third power, I now have a power raised to a power. What is the law? Now I multiply 2 times 3 to give me x to the 6th power. Okay, now normally when we were just dealing with x's and y's, when we do division, we would simply cancel. But I want us to remember what the rule states, because we're about to be dealing with irrational exponents, exponents that have radicals in them. Okay? What do you do when you're dividing? What do you do with the exponents? Okay. These simple rules we are about to apply. Even though the questions themselves may seem complicated, these are the rules that we're going by. What am I doing? Am I multiplying these two bases together? If that's the case, then I'm going to add the exponents. Am I raising a power to a power? If that's the case, I'm going to multiply the exponents. Am I dividing two identical bases? In that case, I would subtract the exponents. Now let's refresh our memory on how to work with radicals. Okay, because our exponents are going to be radicals. Addison, let me know when you're done. Okay. If I have two radicals where the radical expression is exactly the same, can I add them together? Yes, they are what we call like terms. Now, what do I actually add?
The one on the outside.
The number that is in front of the radical. Now, here there is no number in front, but it's understood to be what? It's understood that this is 1 square root of 3 plus 1 square root of 3, which would give me 2 square roots of 3.
Is it still laws of exponents?
No, these are no longer laws of exponents. This is working with radicals.
The ACL.
Yes. Now, when you're multiplying radicals, do they have to be alike?
Yes. No.
No. It's just like multiplying variables. You don't have to have them alike. How do you multiply these two radicals together?
You multiply the thing under the radical.
The two numbers under the radical are combined to give you the square root of 6. And finally, if I'm looking at the square root of 50 plus the square root of 32, as they stand, they are not alike. But is each radical simplified?
No.
No, it's not. So the first thing I've got to do is simplify each radical. 50 is the product of 25 times 2. 32 is the product of 16 times 2. Our laws of simplifying radicals state that you cannot have a perfect square under a square root. because we can actually simplify that. The square root of 50 simplifies to 5 square roots of 2, and the square root of 32 simplifies to 4 square roots of 2. Now can I add these two radical expressions together? They are alike because the radical is exactly the same. Does the radical change when I get an answer? It's still the square root of 2. All I'm adding is the 5 and the 4 to give me 9 square roots of 2. So the laws of exponents that I just wrote on the board are going to be applied in today's lessons, as well as how to work with radicals. Adding them, subtracting them, multiplying them. Okay? All right. Let's just jump into it. And remember, never mind, I'll point on it whenever it gets there. Okay. If I asked you to simplify this expression, the first thing you must make sure is, are the bases identical? Because if the bases, B-A-S-E-S, are not the same, then you can't combine them anyway. All right? But, yes, they are identical. What operation am I doing to the 2 and the 2? Multiplication. So according to the law of exponents, what do I do with the exponents?
Add them.
I add them together. All right? Now, when we're working with radicals, can we actually combine those two radical expressions? No. So that's your final answer. Okay? You've simplified the expression by writing basically, you've taken a base of 2 that was written twice, and you've written it as a single base of 2, and you've showed what the exponent is.